So thank you very much, Thomas, for the short introduction. I will give the first talk of this session here, and I will try to build a little bit the bottom line of the whole story, so Claudio can afterwards also talk more precisely about his certain project. So I will give a kind of an overview of how vocabularies and linked data fit together, especially in the area of NGOs and NPOs. So my talk is, or the title of my talk is Big Data for NGOs and NPOs, Linked, Not Stirred. That's a little bit loosely based on James Bond, as you can see, and the whole thing here is we are facing a kind of a hype at the moment. Everybody talks about big data, and as a linked data guy, as I would say I am a linked data guy, I'm a little bit confused about why big data is so exciting for all the people participating in this discussion, because where is the quality of all the data? It's not tackled by big data, and the question here really is, okay, how can linked data help the big data guys to get a better overview of what they have? So that's the question here, and the challenge, especially in the NGO NPO sector, I would like to start with. So we have several, sorry for that. It's okay, we'll remove that. Sorry for that. So, okay, let's start again. So, what you can see here is a typical situation if you're working in the NGO NPO sector. You probably have a couple of colleagues in other communities, and one is talking about energy efficiency, for instance, the next one is talking about sustainable development, and so on and so forth. But in reality, there are a lot of common interests and a lot of common topics, but the question really is, okay, how to organize all the information which is produced by certain NGOs, NPOs. So each organization kind of has built its own strategy or its own idea of how to organize loads of data. If you look at FAO, I think Claudio will tell you afterwards, there are terabytes of data produced per year, and the question really is, okay, if FAO, for instance, does it this way, does it work for the other NGOs? Are they able to make use of all the data which is produced by FAO? For instance, Semantic Web Company works together now with, I would say, 4 or 5 NGOs in that sector already, and all of them have its own view on sometimes very common topics which they have in common. But the problem really starts with the question, how can they communicate about the same topic? And each community has its own vocabularies, obviously, and on the other hand, how can we manage all the data which is produced by the different communities and different NGOs, NPOs on different continents, also, as we can see later on, that this still somehow works together and is linked to each other. So that's really the big challenge here. So it starts, simply spoken, with this typical Babylonian language confusion. If people from water management talk about wastewater treatment, probably people from working in the renewable energy sector don't understand the same thing. I mean, they have, of course, also a concept of wastewater treatment, but as soon as they discuss this topic, they have completely different things in mind. And it sounds a bit trivial, but still, to my opinion, you can see that in each community. If let's say big data guys now talk about scalability, it means completely different things than if we are in the linked data community, for instance. Scalability is something else, to my opinion. So even if it seems like we are very close, our way of thinking, our communities are at least very close, it's still something we really have to discuss before, for instance, we start a project. So if we start a project together with, let's say, a neighbor community, it's good to have kind of a glossary at the beginning of each project to discuss the most central concepts behind all these different words. So that's something which I can watch very much in the NPO and NGO sector at the moment. So for instance, if we talk about energy efficiency, for instance, energy efficiency in buildings, in Europe, if we talk about certifications, it's probably the same concept as like in the US, they say rating for the same thing. So obviously it's also good to have, even inside of a community, something like a controlled vocabulary, being able to have means to find out what is meant in this document if they talk about certification, for instance. So that's a typical, I would say, sign of having more and more global knowledge networks on the one hand, but still on the other hand having very localized vocabularies and localized concepts. So to overcome this problem, you could talk about localization, and in a localized world, we should have kind of means to understand each other better. So one way to do that is to publish these aura and controlled vocabularies as linked open data. That's one way to do that. And last but not least, there would be a lot of opportunities to link all the data to each other if we had kind of a metadata layer in common. And here exactly actually the linked data approach comes in. So if we have questions in common, and I would say people from water management, from sustainable development, and so on and so forth, there are a lot of questions they have in common. And the problem really is they can't link their own data with the others in a very efficient way. So for instance, if you want to have a more holistic view on things like energy management policies, it would be nice to have different data and different articles and things from communities which also talk about the same topic as you've done probably the last 20 years. But most often people always go to the conferences and read the articles from within their communities, and the reason sometimes really is because it's hard to find stuff because the vocabulary is just not the same, or at least means something else. So that's something which could be solved also with a linked data infrastructure, especially if all the different vocabularies would be linked to each other in a more efficient way. Okay, how can we do that? First of all, we know there is a lot of data. At least now we have more overview, a better overview, since the open data and linked open data and all the data markets and the data hubs and things like that became popular. It's more and more clear where good high quality data is available. So that's at least a starting point now. So if for instance this elephant, okay, is a good let's say symbol for this confusion, because at the end of the day everybody talks about the same concepts, but it's this little story when blind man came to an elephant and the one touched his feet, for instance, and said it's a tree, and so on and so forth, and all the different parts of this whole big picture of this semantic puzzle, as I call it, are already there, but it's not well developed as a holistic view. And to my opinion, linked data and linked open data could be part of a solution for that. So it's about finding the needles in the whole heap stack. And if you have really complex questions like the one I've written down at the bottom, for instance, which policies in the area of renewable energy have helped to initiate projects and programs in the agricultural sector, which finally have improved substantially the nutritional situation in a certain country. I don't know if there's a really, let's say, an answer on that already available. Several experts from several communities have, let's say, parts of the answer, but not the whole answer. And the data, at least, would be there probably to find out a more accurate answer. But first of all, we have to find where the spots in this huge big data collection. And the next step is to link those data sets to each other. And I would assume that most of the attendees in this webinar are coming from the linked data community. But still, it's not clear for most people outside of this community that it's possible now with the semantic web standards to make links between these data sets in a very efficient way. So let's take a look on the solution approach. How could this work? And to my opinion, it's very important to establish a linked vocabulary infrastructure first. So if you look at the linked data cloud at the moment, there's a lot of linking between the data sets without reference points. I mean, in the middle you somehow have DBpedia as a reference point. That's nice, but it's a very, let's say, common sense repository. It doesn't serve for many communities, for special interest communities and expert communities. So first of all, if you want to link data within a certain domain like food, agriculture, renewable energy and so on, you need to have kind of a well-developed thesaurus in the middle. And those kind of vocabularies are means to link to other communities. As a hub, these reference vocabularies can serve as a hub to access the instance data later on. And there is SCOST, a simple knowledge organization system provided by W3C. It provides a couple of such linking properties which are standardized. So for instance, the SCOST exact match property can tell you, okay, there is a concept in the one vocabulary which corresponds with a concept from another vocabulary. And for instance, if you look at the, let's say, renewable energy thesaurus, which is provided by REAP, the real thesaurus is already kind of a standard in the, or at least a very good reference point in that area. So if you have a concept there which talks about liquid hydrogen storage and you would like to link it to a corresponding concept from the sustainable development community, you can do that with such SCOS properties like exact match. And you can see here a little screenshot of the pool party thesaurus server, which helps you to do that semi-automatically. So you can do a link here in between, and we will see in a few minutes what can do that for you if you have that link already in place. So as you can see, first of all, those different communities have different contexts for each concept. That's the first of all the most important reason to have such links in between, because then you better understand later on what the others are talking about when they say liquid hydrogen, for instance. So as you can see here on the left side, the blue ones, they have different maybe synonyms for the same thing. They have probably another broader, let's say, hierarchy on top of on liquid hydrogen, like, okay, it's a hydrogen technology. And the renewable guys probably say that's a storage technology. And also the relations, this concept would have like full efficiency on the one hand, and the others probably see it more related with pressure accumulators. So it's good to know what others actually have in mind or which context to build around a concept when they talk about liquid hydrogen. That's first of all a very high value, which we shouldn't forget about. And on this picture you can also see once again that those reference points, which can build for each by each special interest community, can once again be referenced by, let's say, a more top-level reference point like DBpedia or Freebase. So this alignment obviously is key, and the question really is how can we manage to do that kind of semi-automatically at least. So there are three tools I would like to propose for that. First of all, there's Silk. So there's also the link here. The slides will be downloadable, and as Thomas already said, there will be an email for all of you, so you will get all these links. Then there is another framework for linking data more or less automatically, which is called Limes, and then there's the pool party thesaurus server, which can do that for you. So now, last but not least, I would like to go into some generic applications. What can we do on top of linked vocabularies? So first of all, I think it sounds a bit trivial, but it's very valuable if you can query third-party data in your own language. So as we've seen just before, renewable energy guys, they probably don't say liquid. They don't say liquid H2 to the liquid hydrogen. But sustainable development people probably use that word pretty often. So they still can use their own language, and if their concept is mapped to the one from the other community, it's good. It works if it's translated. And that's something which can only be built on top of such a linked vocabulary infrastructure. By the way, that's not only important, I think, for the NGO NPO sector. We always see that in when we talk to our enterprise customers too. Most often the citizens or the customers speak a different language, of course, as the people would do it internally of the enterprise. So that's also an aspect always when it comes to translate search queries. So the second generic application use case is to being able to query your own data and third-party data, as it were, in one single database. So, for instance, here, if you go to regal.info/countries, you can retrieve so-called energy profiles for each country, and this super mashup you can see here. It covers like statistic charts and projects and stakeholders, like an actors catalog and events and everything. And this different or this data, which looks like as it came from one single database, was derived from actually 5 or 6 different databases, and the mashup was done completely automatically on top of linked data mechanisms. So that's something which is I would say the second generic use case, to have kind of a dashboard, a complete overview of a certain topic or a country and so on. And last but not least, I think it's became more and more important to have means to link unstructured and structured information much better. So for instance, if you want to have things like show me energy related articles where countries or regions are mentioned whose wind power production has doubled over the last 10 years, just as an example, it's good to have technologies which can help you to link things from, let's say, news feeds and resources which are more, let's say, content oriented in a way of providing unstructured text. And on the other hand, you have statistics agencies which produce high quality data, and those things are most often not really linked to each other. With a controlled vocabulary in the middle, you can do that pretty automatically. And if you can even leave those 3 things, like the articles on the one hand and the statistics on the other hand, and probably the thesaurus as a third source, where it is, you can leave it in different databases. And still, if you have Spark endpoints on top of those 3 things, you can link it by querying federated Sparkle queries, and that's doable now with Sparkle 1.1. And I think that's a very exciting opportunity for the linked data community to show that information can be managed decentralized, but still can be linked to each other and provided as it were in one database. So, as a very realistic example, once again, the Regal linked data cloud looks like that already. So you can see there are a couple of let's say links between different data providers already in place, like World Bank, UN Data, Eurostat, and so on and so forth. The countries play very important role to link data to each other, of course. Then also the Regal thesaurus, the glossary, is linked to things like the GEMET thesaurus or the Freebase thesaurus. Actually, it's not a thesaurus, it's a knowledge graph, as Google says. And then we have actors, for instance, which were linked to DPpedia. So there is a good opportunity now get networked in a way that you can build mashups together with other NGOs, at least in the sector of renewable energy here. Yeah, so what's the conclusion? So the final conclusion is, you know, there's a lot of discussion going on, especially in the governmental area. Why should we provide linked open data? Open data should be actually already enough. Okay, so yeah, I mean, from a government point of view, that's true. But if you look on the value chain, on the bottom where the linked open data approach comes in, the question really here is, what is an NGO? Is the NGO rather a media and data broker? Is it providing things like information professionals usually do, like publishers and so on? Or then I would say the linked data approach comes into the central idea of how to publish open data. If an NGO rather acts like a typical government organization, then I would say, okay, it's probably enough to publish all the data as, let's say, raw data, as CSV files, whatever, and others should transform them more or less into linked data. But I can't imagine really that with a lot of open data which is around now, any really interesting value chain and business could be built on top of it. Here we really need something like linked open data, and yeah, that's probably something we could discuss at the end of this webinar, and that's my hypothesis I've put here, and we will see if that becomes true or not. So that was it from my side now, and I would say I would like to hand over to Claudio, or first of all to Thomas maybe. So Thomas.
Thanks, Andreas. Thanks, Andreas. Yes, as Andreas said, for all those who have questions, please use the chat or the questions box in your webinar software. And this is now to introduce our second speaker, Mr. Claudio Baldassare of the Food and Agriculture Organization of the UN, based in Rome. Hello, Claudio. And hello. A short introduction. Claudio is a software engineer with several years of experience in the research and development of information systems based on the semantic web. In particular, over the past 6 years, he has focused his hands-on experience on bridging the gap between non-semantic data stores and semantically enabled enriched systems, both in the context of international organizations and in the research environment. In addition to technical skills, he also performed as a leader and coordination person in the context of projects focusing on or adopting semantic technologies. Today, Claudio speaks about the Fisheries Linked Open Data Project, data harmonization with semantic technologies. Claudio, it's your turn.
So, thank you, Thomas. Can you see my screen, yeah?
Yeah.
Okay, shouldn't see this, yeah? Okay, thanks for the introduction. Most of the concept that Andreas introduced will be instantiated in my presentations. That's because I will talk about harmonization and interlinking and our experience in the fisheries divisions in FAO. So I have organized these presentations in two sections, one of which I know I will not be able to talk about, but I invite the technology provider who are in the audience to have a look at this second part of the slides, because there can be opportunity for us to liaise in the future. What I will talk about is instead what is the Fisheries Linked Open Data, touching on harmonization through Fisheries Linked Open Data, domains interlinking, and application scenarios. And then I go through a brief list of which application we have built which consumes the FLOD. So what actually is the Fisheries Linked Open Data? As Andreas mentioned, there is a problem, there is a challenge about reference terms which should be disseminated into an organization and through organizations. In fisheries, we have this list of terms, and we also have a list of codes which are organized in code list. FLOD is a version of linked open data of these codes and code lists which pre-exist in the fisheries divisions. Besides having codes and code lists, we also have terms which are associated to these codes, and these terms usually are the ones which are selected and authorized to be published in yearbooks or web portals. That's for political reason, of course, being an international organization. And these slides, you also have examples of code lists for fishing gears, fishing vessel, and fishing area and marine species, and how they have associated terms. Here they are reported in English, but they also have translation in all of the 6 languages we have that are official in FAO. And beside this, without collecting codes and code lists, FLOD is a dense network also of cross-domain relationships. Now that will be clearer for you when I will go through the application, but to give you a taste, a cross-domain relationship that we have set up are about, for example, country having a sovereignty on exclusive economic zone, or a country participating in a fishing agreements. That will be clearer for you. So who we serve later? Who we serve? We serve fishery communities of practice inside and outside FAO. Mainly they will be statisticians doing their reports, catch reports, statistical catch reports, or marine scientists doing their assessment on species, whether they are endangered or not, for example, or content managers, people that populate the web pages in institutional portals. So for those of you who have no idea what a purseines or purseiner system, this is what a vessel using purseines was mentioned in the previous slide. Okay? So how and why did we realize harmonization, and why did we need it? So historically, the motivation, in fact, stems from a need that statisticians have shown. In their daily activity, they will collect data from regional level, let's say to connect to what Andreas said, a local level, to a global level. Well, global level is FAO level, the level where we produce the reports. When the statistician collects this data, they will have a tremendously heterogeneous format, use of language. So typically in places where they speak French, they will use French names for fish, or they will use local codes lists for referring to a species, or for referring to a fishing gears, or for referring to a fishing vessels. Or they will report at different granularity. Someone will report at sub-area level, some other will report at subdivision level, or subdivision level. So statisticians face this issue that they have to reconcile all of this data. And they've done this manually in the years. So what we decided with FLOD is that we can capture this knowledge that they have into an artifact which materialized the harmonized code list from local to global level, so that they can be then injected into processes of processing statistical data and support the statistician in their work. Once we have created the first version of codes and code list, essentially in the fishery domain, in the fishery statistics domain, we realized that the potentials that we have was far beyond that. We could not only support the statistician, we could provide benefits to other classes of users. So what we did, and we had this, let's say, this intuition when information officers in fisheries had formulated this competency question which you see at the bottom, which is very complicated but not very different from the one that Andreas has listed. We understood that the codes could have been the core of FLOD, but then we started to build other data sets around this code, which anyway would have been the bridges around the data in these domains. And we saw included land and geopolitics, land geopolitics, marine geopolitics, fishery techniques, fishery legislation, and fishery baskets. That's all. And then we started to establish cross-domain relationship, and the drivers for which relationship we chose, or which were the one that had more attention from us, were given by competency questions actually asked to the real users. So you can see some of these competency questions on the screen, like, for example, what is the amount of fish caught in 2008 in Danish exclusive economic zone by vessels that practice fishing with traps? So you have other examples here, but it's already clear what these competency questions need to capture, which concept and which relationship should have been part of FLOD, so that we can actually provide with systems and application satisfying these user needs. After we had completed or partially completed the second version of the FLOD, we started to realize, or to think what were the application scenarios. So where this could be useful, this knowledge that we capture in the FLOD could be useful. And we had specific case studies, like the reallocation of catch statistics based on geospatial information, or the fact that we could generate landing pages populated with data from remote open linked data sets. So not only FLOD, but also getting the information from other existing data sets. Also, we could enhance existing search engine, which would exploit the network of connection in FLOD. And last but not least, the fact that we could aggregate documents in the user information context without necessarily asking the user to formulate a request. So these are the main application scenarios we are looking at. And now I will actually list what we have in terms of products. Some of them are in ongoing development. Others have reached stable version. Others are only proof of concept. So this one in particular is the FLOD portal. It's in its early version, and is the interface for users to access the content in FLOD. What it features is mainly two things. One is the search into the network of entities, and by doing so, it offers multilingual autocompletion to avoid spelling errors. And once the users has selected, has found the entity, which of course goes with a cause and with a control term, it can browse the equivalent codes from other code lists which have been mapped, but also the translations for which the terms as values, different values. Besides that, we offer the possibility to know what are the related publications in the collection of fisheries publication by the fact that we have annotated those publications with the entities using the names which occur in these documents. We offer another level of information here, which is the metadata on provenance. So who is the publisher of the information they are seeing, who is the rights holder, and what is the system of provenance. So all of this information actually respond to real need that we have inside fishery division. And of course, all of this data are exposed through the FLOD Spatial endpoint. So you can actually either use the interface, or for application, they can directly query the Spatial endpoints. The second way we use the portal is we offer the users the possibility to search directly the collection of publication. When they do so, they still they will still have the support for multilingual auto-completion of the terms that they use, or they can simply use free text. And the result will feature a list of entities in FLOD, which you can see at the bottom, that annotate the particular, the specific publication, and they can also see where in the text, in the pages, the terms that they have searched appears. So this is a particularly useful use of FLOD, because so far the collection of publication have been randomly being managed, but in this way we can actually create a network of publication, although they belong to different collections, through the fact that they are annotated by entities which by themselves are connected. This application is mostly a reuse of an idea of injecting in the user information context some knowledge which come from a FLOD Spatial endpoint. So essentially, we don't ask specifically the users to make a search or to request the information, but we populate by scanning the web page content with links which are then connected to additional information which come from the endpoint. So the yellow highlighted words that you see, they correspond to entities in FLOD, and the hyperlink that is created can be customized in terms of behavior. So if the user decides that clicking on the highlighted terms will show, for example, all the documents which belong to that entity, so all the pictures that belong to that entities, or for example, all the alternative code lists that are present in FLOD, this can be actually brought to the user with less effort, low effort. In fact, this is a feature which is distributed as a bookmarklet, and this has obtained quite a response by our users. This is the applications that most intensively make use of FLOD data. It's a time series spatial reallocations. The questions that, the issues, the challenges that tackles this application is how can statisticians reallocate statistically the catches that have been done, that have been reported at the regional level into another granularity of marine area, which are the exclusive economic zone, which are the one which you see outlined with a dotted blue line. So the scenario here is that there exists time series which are referenced by water areas which are not exclusive economic zone, and the goal is to recalculate these quantities of catches in the area, in the exclusive economic zone that are selected. So the process that allows for spatial reallocation retrieves, first of all exclusive economic zone where a country is allowed to fish. Now, this is modeled in terms of relationship. We have relationship that says a certain country is allowed to fish legally into a number of exclusive economic zones. This is for either on legal basis or on basis of fishing agreements which are set up with a certain time frame. So let's say for a period of 5 years, a certain country is allowed to fish along the coast of the economic zone where it doesn't have sovereignty. Okay, so first the applications ask for the list of exclusive economic zone. Then it retrieves references of species codes that from the existing time series might not be the reference one. Okay, for example, let's say ASPIS is the reference code list for species, and the time series reports species codes from other code lists, like for example taxonomic code. Then there has to be a reconciliation of these codes according to the global one, to the reference one. As a third step, the application asked for spatial intersections of fishing areas. So the exclusive economic zone overlap another segmentation of areas. So to understand what are the sections of the exclusive economic zone which has to be considered, we have stored in FLOD also information about C-square, which is a segmentation of areas on the globe, and we can respond also this query of this request. As a last request that the application does is retrieving the fishing rights based on the fishing agreement. So as anticipated before, not only a country can fish in its own exclusive economic zone, but can also fish in other area by fishing agreements. So when the application has had all of this data coming from FLOD, it can then run its processes of spatial reallocation, which are essentially statistical algorithms that treats the time series data let's say in a statistical fashion, coming up with a second version of the time series, which now respond to the correct granularity of area. So this was a bit long explanation, but as I said, this is the application that most intensively make use of the connection in FLOD. And finally, I will mention also this proof of concept, which still elaborates on time series. But what it does, it takes a time series as a raw text, mines the FLOD entities into the time series. So, for example, if he mines the species, he mines the water areas and the country, then leverages all the information, all the links that are instantiated between species, water areas, and country, and finally generate a KLM model that includes the reference to the entities you realize that have been mined, and then reorganize the time series records along a specific dimension, which here I show the specific dimension are the water areas segmentation, but you can also reorganize the records along the dimension of what are the countries. This was the last example of application we have been built, and the conclusions that I can report to you is that we have with our experience in FLOD, we have seen that this can fairly represent a source of harmonized reference data, and also a source, a hub for control terms that the application will use for the application of statisticians and marine scientists will use. FLOD is consumed by applications that are either in need to aggregate data instances like statistician, or aggregate the documents, images, maps, which are relevant to the user need. FLOD is also representative of an approach to the maintenance of linked reference data sets. And if this proves to be successful, we have an initiative in FAO at the corporate level, which is called Master Data Management, for which our experience is very useful, because we are the one which is pioneering this use of semantic technologies in maintaining and managing control terms again with semantic technology. So we are somehow setting the basis for the experimentation of tools and practices of having not only control terms but linked control terms. And that would be all.
So thank you, Claudio.
Thank you.
Thank you. So this is time for questions. You can still give them in the chat box or raise your hand. There are buttons on your interface to raise the hand, and I will give you the microphone. Claudio, I have one question to you. The control vocabulary you have done with the different names of fish and legislations and so on. Is this feedback into the LOD cloud?
We have an openly accessible Spatial endpoint, but we didn't yet publish this into the LOD cloud. That's because we are still running tests of stability of URIs, and we want to be sure that once we publish it, they can be stable and of reference for those who will use it.
Because I think your example of this vocabulary is a good example that you have a more maintained and a better and in-deep knowledge of a specific domain, better than let's say Wikipedia or so. Wikipedia. So it would be good to have it in the cloud.
Yes. In other words, we are building our own reference data set for which we can align with DBpedia, but that will not be a reference for us. It will be more an entry point for users which use or application which use DBpedia concept and instances to enter our linked data set.
I also have a question to Claudio. What I would be interested in is if you have the challenge to being able to differentiate between data which is publicly available and maybe in the same graph, even there are some triples or parts of your knowledge which you would like to have kept internally. Do you have any access rights discussions around your triple store?
That's a good question. We are short in this respect, in the sense that we are having roundtables about governance and governance and policies of data access, and from providers and for consumers. And the first thing we want to understand is what is the best license schema that we can apply to our data, and depending on the license schema, then we eventually define access rights for more confidential data. But overall, we as FAO, Fisheries Division, at this level, we don't have issues on access because FAO publishes everything. So in our case, all the data that we own is publicly available. But we have requests from users or from other institutions that concerns the access or the visibility of the data.
Okay. A rather technical question I would be interested in: which RDF store do you use?
We are using GNAM, and we have an on-disk persistence, the TDB, and we have implemented a quad store actually. And that is how we can relate graphs or data set to meta information like provenance, rights holder, and publisher. So this is how we set our infrastructure.
Okay. Thank you.
Maybe a question to Andreas. So I think the FLOD project is a good example how NGOs are getting more and more the central hubs for domain knowledge and so on, and leave the former central hub for the LOD cloud, where everything is connected to the DBpedia more behind. How do you think this change will happen from the connection activities to the different NGO linked data providing facilities?
Well, I think my last slide, when I was asking who will play the role as the information professional between enterprises and governments, I think that's the perfect role of NGOs. I think there are a lot of information professionals there. If you think of organizations like, I don't know, OECD, they traditionally act as a kind of a publisher, and I think, I don't know, Claudio, correct me, but I think FAO, at least half of the activity at FAO is kind of a publishing, or what has been always been kind of a publishing activity, and I think it's a good time now to have DBpedia and all the others somehow as a bottom line, as a first version of a linked data cloud, and building on top of that a second layer, more let's say a layer which is more going into certain communities, certain fields of interest, together with people who have a deep knowledge about a certain domain. It's a very good second round now, which will happen, and I think NGOs will play the most important role here. And then after that, together with the publishing industry, I think enterprises will step in, because many people always ask, where's the value for enterprises? Why are enterprises not participating with open data activities so much? And I think really that it's the third round they will step in, so maybe in 2015 or something.
Yes, if I can add something to this, we have a keyword here, which is authoritativeness of data. Although DBpedia plays this hub role in the linked data, for us, not really authoritative, an authoritative source. That's why we are setting up this Fisheries linked open data core around code lists, which are authoritative for FLOD, for FAO, and they are also an authoritative source for all the partners we deal with the Fisheries division. And another thing that I would like to add is that using linked data set for vocabularies for control terms allows us in the long run to see a decentralized maintenance strategy where the owner of the mapped code list can take care of their own data, and we simply will manage the mapping, the core of the mapping between our own code list and all the satellite code lists which exist in the regional fishery bodies, which are the one that feeds us with data. So this is a real long-term objective that we are pursuing, so we don't have to take all the effort of manually maintain the remote code list for terms.
Okay, so finally I open up the microphones. If there are no questions in the chat, I open up the microphones to, you can say a goodbye or have a comment or some question again. So this is more experimental. Maybe there is some noise and we have to stop, but let's see. Okay, there's some music. Okay, so you are online. If somebody wants to talk, now it's your turn.
Claudio, I think that the work of FAO in the domain of semantics is somehow always a little bit advanced to other organizations. I just think about AgroVoc and about what you have now presented, the FLOD. Do you think that you can foster this position, let's say, telling other organizations or demonstrating how successful your work is?
At the level of the whole organization, we have the data.how.org project. Now, although the data.how.org project does not mentioned the fact that they're using a triple store. It is in fact using the triple store. So somehow we have pushed internally between the team of Agrobot and my team. We have fostered the use of linked data set. So, and it's also envisaged that part of the triple store that is powering the data.FLOD would be in the near future, let's say mid-2013 maybe, will be exposed publicly so that other organizations can start to link to the data set produced internally to FAO. So I would say we are on a good, we have good premises that this can be adopted by the organization and eventually give a good example.
Mm.
So I would use this 10 seconds to remind that my presentation also contains other slides which tells about FLOD and master data management in terms of objectives, challenges, and current status. For the technology provider which might be in the audience, I suggest that you have a read. And in case you have suggestions how we can overcome certain challenges, you can contact me back.
Okay. Thank you, Claudio. Thank you, participants. You will get an email in the next hours with a lot of links in there to have some follow-up activities. You can contact Claudio, you can contact Andreas, and you can look out for the next webinar, which is in the plan. So look on our blog. It's blog.semantic-web.at. So have a good day. Bye, Claudio. Bye, Andreas.
Bye. Thank you.
Bye-bye. Thank you very much. Ciao.